So let us do some examples of successive differentiation or higher order derivative. First let us start with some easy question. So it will be easy for you to understand. Then we will go to some different types. So y equals to x cube plus 7x square minus 2x minus 9. This is the first question given, where it is asked to find the second order derivative. Second order derivative means we have to find the derivative 2 times there. So the first derivative of this we will write dy by dx, and as you know the derivative of x cube will be equals to 3x square. Derivative of this one will be 2x, so 7 is there, so it is 14x, minus derivative of 2x is 2. So this is the first derivative. Then we have to find the second order derivative, that means d by dx of dy by dx. So in this manner we can write, or directly you can write, if you understand, directly you can write d2y by dx square. This part can be written as d2y by dx square. Then we have to find the derivative of this function. So now you see x square is there, so x square derivative is 2x, and here 3 is there, means it will be equals to 6x, plus 14x derivative will be 14, x derivative is 1, so derivative of 2 is 0, so no need to write that one. So the derivative, second order derivative of the first question is 6x plus 14. So in this way you can find the derivative, you can see very easy. First derivative you need to find, then find the derivative of the first function or first derivative which you have got. That is called second order derivative. Now the second question, it is given to you that y is equals to sine log x. Second bit it is given y is equals to sine log of x, and we have to find the second derivative of this one. So for finding out this one, first you find the first derivative of this dy by dx, so which will be equals to cos log x. So as you know the derivative of this sine is cos, so cos, and in the angle log x is there, so that log x we will write. So as you know, here we have to apply the chain rule, so d by dx of log x we will write, because in place of x we have log x, so we have to find the derivative once again there. So this is equals to cos log of x, and the derivative of log x is 1 by x. So the first derivative of this one we got 1 by x into cos of log x. So this is the first derivative, but we need to find out the second derivative, so we will write d by dx of dy by dx, or you can write this one as d2y by dx2, and the derivative of this we have to find out. For finding out the derivative of this, either you can apply the quotient rule or you can apply the multiplication rule. I am applying here multiplication rule, you can try with the quotient rule also, same answer you will get. So multiplication rule says is that first function into derivative of second derivative means cos x derivative, cos derivative is sine, so it will be minus of cos derivative is minus sine, so minus sine of log x. Then we have to write the derivative of log of x, derivative of log x, chain rule we are applying, then plus derivative of the first function means derivative of 1 by x. So derivative of 1 by x is minus 1 by x square, and this one will be cos log x. So if you remember the formulas, as I said, it will be very easy for you to understand. So here we can write minus 1 by x sine of log x, and the derivative of log x is 1 by x. Then this one is minus 1 by x square into cos log of x. So here you can see x into x, it is 1 by x square, so minus 1 by x square you can take common from both, and you can write this one as sine of log x plus cos of log x. As we have taken minus common here, so it will become plus. Minus I have taken common, so it will be plus. So this is the second derivative of sine of log x, which is minus 1 by x square sine log x plus cos log x. Like that we can find the second order derivative. So these two are the simple questions just to understand the basics. So I think it is clear to all of you there. Now you see that the second question. Now from here, what questions I am solving here, these are some typical questions there. In the book you will find out that mainly these 4 to 5 types of questions are there. So all will be similar to that. So if you understand these 4 questions or 5 questions there, you can solve all the questions from the exercise there. So let us see the second question here. And remember, in exam, if a second successive differentiation comes, generally it comes of this form. Either proving questions or like this question which I am doing here right now, that type of questions are asked there. Because it is a 4-mark question, so it will be like this. Not very simple questions are generally not coming. coming, but you have to know the procedures there. So let us see that what is given here. It is given x equals to a cos theta, y equals to b sin theta. We have to find d square by dx, d2y by dx2 at theta equals to pi by 4. So that is the later part at theta equals to pi by 4. First we need to find d2y by dx2. That means the second order derivative of y with respect to x. But here you see x is in terms of theta, y is in terms of theta. So this is called parametric form, as we have done in case of differentiation previously there. This is a parametric form. So x is equals to a cos theta it is given. So first you find the derivative of x with respect to theta, dx by d theta. So dx by d theta will be minus a sin theta. A is constant, so cos theta derivative is minus sin theta, that we got here. Then you find the derivative of y with respect to theta, dy by d theta. So here we can write b cos theta. So we got this one as b cos theta. Actually we need to find dy by dx. So for that dy by dx we will find out. And as you know, in case of parametric form, we can find dy by dx by dividing dy by d theta by dx by d theta. So dy by d theta we got b cos theta, and dx by d theta we got minus a sin theta. So the result is minus b by a cot theta we got. You know, cos by sin is cot. So minus b by a cot theta we have got here. So this is the first derivative, dy by dx we got. Up to this I think it is clear to all of you there. Now we will find out the second derivative. Here little bit more carefully you try to understand. Second derivative means d2y by dx2, and we need to find the derivative of this part here. Derivative of minus b by a cot theta. So for finding out the derivative of that, minus b by a is a constant, so it can be taken out, and we need to find the differentiation of cot theta with respect to x. Remember this, we are finding the derivative with respect to x. So d by dx of cot theta we are finding out. So minus b by a you write. Cot theta differentiation, as you are doing same way you write. Cot theta differentiation is minus cosec square theta, that one you are going to write. But here theta is there and we are finding differentiation with respect to x. So one more term will be written here, d theta by dx. By applying the chain rule, it will be d theta by dx. So the answer will be minus minus, this one will be plus. So b by a cosec square theta, and d theta by dx. We have found out dx by d theta. Here you see that we have found out dx by d theta, which is minus a sin theta. So d theta by dx will be equals to 1 by dx by d theta. So that means it is minus 1 by a sin theta. So minus 1 by a sin theta we have to write here. So minus 1 by a sin theta is actually equals to 1 by a cosec theta. You know, 1 by sin theta is cosec theta. So here you can write minus 1 by a cosec theta. So the answer of this part is minus b by a square, because a is multiplied into cosec cube theta. So into cosec cube theta. So that is the differentiation, or the second differentiation of this d2y by dx2 we got. But in this question something more is asked here. It is asked you to find the value of this one at theta equals to pi by 4. So I am writing here on this side. So we got d2y by dx2, which is equals to minus b by a square into cosec cube theta. But we have to find out its value at theta equals to pi by 4. So at theta equals to pi by 4, you can write in this way also the notation d2y by dx2 at theta equals to pi by 4 will be equals to minus b by a square into cosec cube of pi by 4. And you know cosec pi by 4 is root 2. So minus b by a square into root 2 whole cube it will be. So root 2 whole cube is minus 2 root 2, and this is b by a square. So this is the answer of this one. That means derivative of this one, second derivative of this one at theta equals to pi by 4 is minus 2 root 2 b by a square. So the method is simple. As we are doing the differentiation, same method we are applying. Just only one thing is that we have to find the differentiation 2 times here. So that is the second question here. Now the third question is a proving question. So this type of proving questions are more important for you. So let us see how to solve this proving question here. So this third question, it is given to us that y equals to cot x, and we have to prove this d2y by dx square plus 2y dy by dx equals to 0. Okay, so first to find the derivative of this first derivative dy by dx. So as you know, cot x derivative is minus cos x square x, we will write. Then we will find out the second derivative d2y by dx square. So derivative of this one we will find out. Minus sign you keep outside. Derivative of cos x square will be equals to 2 cosec x, 2 cosec x, then d by dx of cosec x we will write. We are applying chain rule here. So this is minus 2, minus is kept outside there. So minus cosec x into cosec x derivative is minus cosec x into cot x. So as you know, the derivative of cosec x is cosec x into cot x. So minus minus will be plus, so we will get 2 cos x square x into cot x. So this is the second derivative of this function there. So first step what we have done, we have found out the first derivative and the second derivative of the function. But here it is asked you to prove something here. So what we need to prove here, this d2y by dx2 plus 2y into dy by dx is equals to 0 we need to show, is equals to 0 we need to show. So we got d2y, we got dy by dx, and y is also given to you in the question. So we'll substitute those values and we'll check whether it is giving you 0 or not. So d2y by dx square is 2 cos x square x into cot x plus 2 into y. Y value is cot x. So you substitute that value of y. So here you can see y value is cot x. So you can substitute that y equals to cot x. And dy by dx. dy by dx we got minus cos x square x. So it is minus cos x square x. So this is 2 cos x square x into cot x minus 2 cos x square into cot x. So this 2 will cancel and the result is 0. So that means we have proved the thing which is asked to you here. So in this way we can solve. See, when we are doing proving question, so I will show you 3 different types of proving question which I have taken as an example. These are 3 different types of question. So in the first question which we have done, we have found out dy by dx, we have found d square y by dx square, that we have taken, those values we have taken in the LHS and we got the RHS. In this way we can solve one. Now the second type of question is there, which is a proving question no doubt, but the method will be slightly different. So let us see what is the method. First method is, you remember the first method, then we will go to the second part. Now see the fourth question. It is given y is equals to log x plus root over of x square plus 1. Here also something similar to that, it is asked to prove equals to 0 there. So just you do the differentiation as we are doing. Dy by dx first you find out. Derivative of log x. You know derivative of log x is 1 by x, so we will write this one as 1 by x plus root over of x square plus 1. Then we have to apply the chain rule, that means d by dx of x plus root over of x square plus 1 we will write. So this is 1 by x plus root over of x square plus 1. Then the derivative of this part, x derivative is 1, derivative of root over of term is 1 by 2 root over of x square plus 1. Then derivative of this inside part, remember chain rule we are applying, so root over something x is there, then 1 by 2 root over of that part, then derivative of inside part, x square plus 1 derivative is 2x we will write. So this 2 cancel, so 1 by x plus root over of x square plus 1. Here you take the LCM, LCM will be root over of x square plus 1, here also we will get root over of x square plus 1 plus x we will get. So here you can see this part and this part can be cancelled, so we will get here 1 by root over of x square plus 1. This is the first derivative. Then we will find out the second derivative of this. So before finding out the second derivative, for proving this one, we will take this term to the other side. So here on the left hand side we have dy by dx. So if you take this one to the other side, root over of x square plus 1 into dy by dx is equals to 1. Now again differentiating with respect to x, we will get, see when you are doing differentiation again with respect to x, carefully observe here, first we will find the derivative of this. Just let us see once again here. So this is x square plus 1 into dy by dx is equals to 1. Now take the square of both the sides. Squaring both sides, because what we need to prove in this one, x square plus 1 is there. So we have to take the square of both the sides, then this one will be x square plus 1, root will be removed, and here dy by dx whole square is equals to 1. 1 square is 1. Now we will differentiate it with respect to x. Again differentiating with respect to x. I am doing it on this side. So we have x square plus 1 into dy by dx whole square. So we will find out the derivative of this with respect to x. So we have to apply the product rule on the left hand side. So first function x square plus 1 into derivative of this. See, when you are finding the derivative of this, as you are doing differentiation, same method you apply. So power is there, so this one will be 2 into dy by dx, then d by dx of dy by dx we have to write. That means derivative of this part. First power is there, so 2 into dy by dx, then again d by dx of dy by dx, plus derivative of this. Derivative of this x square plus 1 will be 2x into dy by dx whole square, and on the right hand side we have 1, derivative of this one will be 0. Now if you simplify it, it is x square plus 1 into 2 into dy by dx, derivative of this one is d2y by dx2, and this is 2x into dy by dx whole square equals to 0. Now you can take 2 into dy by dx common from all the terms here. So this is x square plus 1 into d2y by dx square, d2y by dx square plus x into dy by dx, as we have taken dy by dx common, so dy by dx equals to 0. So this one will go to the other side, or we can say that 2 dy by dx dividing on both the side, we will get x square plus 1 into d2y by dx square plus x into dy by dx is equals to 0. So in this way we have proved. So see the difference in the previous question. In the previous question we have found out the first derivative and the second derivative, then we have put that one in the left hand side of the expression there. But in this case we have used the first derivative to simplify and get the left hand side and right hand side both together here. So this is another way of proving the question there. So in some questions we need to use this part this way, and in some questions we will do like this. Now we have two different proving questions we have done. Now the third type of proving question, let us see there. In this third type of proving question, we will apply another technique here. So see the question, here it is given y is equals to sine inverse of x whole square. So first we will find out the derivative of this dy by dx. So this is 2 sine inverse of x, then d by dx of sine inverse of x, again applying the chain rule. So this is 2 sine inverse of x, derivative of this is 1 by root over of 1 minus x square. Then you take this root over of 1 minus x square on the left hand side. So this is root over of 1 minus x square into dy by dx is equals to 2 sine inverse of x. So see in this question also we need to prove 1 minus x square, not root is not there. So again you take the square of both the sides. So taking square of both the sides, squaring both sides, we can write this one as 1 minus x square, root will be removed, dy by dx whole square, and this one will be 4 into sine inverse of x whole square we will write. 4 into sine inverse of x whole square. So see in this type question, this is the third type of proving question here. In this type of question, after doing the first differentiation and simplifying one or two steps there, you will get the original function once again there. Original function was given y equals to sine inverse of x whole square. So that original function again will come after doing one or more step simplification there. So we got this one. Now we have to substitute this value of the original function. So sine inverse of x whole square is y. So we'll put y value here. So we can write this one as 4y. So finally we got here 1 minus x square into dy by dx whole square is equals to 4y we have to write. Okay. So this is the simplification up to this part we have done. Now we will find out the second order differentiation in order to prove this one. So again differentiating with respect to x, we'll get 1 minus x square into derivative of this is 2 into dy by dx. We have seen in the previous question we have done. So this is d2y by dx2 I am writing directly now. Now plus derivative of this part is minus 2x into dy by dx whole square. And on the right hand side 4y is there, so 4 into dy by dx. Now you divide 2 into dy by dx on both sides. So 2 into dy by dx dividing on both sides. On both sides we will get 1 minus x square into d2y by dx square. As we are dividing, this term will cancel and here square will cancel, 2 will cancel. So minus x into dy by dx. Here this 2 will cancel, dy by dx cancel, so equals to 2. So that is the proof which is asked here. So like this proving questions are there. So you can see that the methods are very interesting and not difficult. Just you need to understand the procedure. So I have done 4 different types of questions. All are different type questions there and different methods are there. So while solving the questions from exercise or the assignment which I will give you there, you follow the same methods there and see how many questions you are having. You can solve them.